so I didn't really need to work on that tonight. But
all right. So
yeah,
this first one here, let me see if I can blow it up a little bit here.
sure. Yeah.
And I guess it, and it shrinks it again. All right. So find the area of the shaded region in the figure to the right. So
Cool.
give me the general equation for the area of that shaded region.
All right. It's pi times radius squared minus pi times radius squared.
Yeah, or it's really the area of the big circle minus the area of the small circle.
Yeah.
You know what I'd like to see you do is
Okay.
start from the initial concept.
Okay.
In other words, when you look at that figure, you know the shaded region is the area of the big circle minus the area of the little circle. And then we can fill in the pi capital R squared minus pi little r squared.
Okay.
And they give you the capital R and the little r. Now notice that you can factor the pi out, but you can't factor the r out. In other words, I can make that look like this, but that's the best I can do.
Uh-huh.
Okay, so that's the area of the shaded region. Substitute the two r's they give you, and you have the area of the, and that is called the annulus.
Okay.
Believe it or not, there's a geometry.
I remember that, yeah. It's like a donut. Looks like a donut, yeah.
A word that describes that. In fact, I heard annulus the other day, and I didn't know what it was. I had to look it up, and this is what it is.
Cool. Yeah, I was confused. Like, our teacher used that term, and I was confused. I was like, yeah, I was like,
you hear it very often.
I asked him,
what
does that mean?
Years of tutoring, I've only heard it maybe twice.
Interesting. Yeah.
No.
It's not a word that you hear often, but yeah.
All right, the length of x in the figure to the right.
Cool.
So you have an angle. You have side 15 and you have side x. So which trig function relates that angle to those two sides?
You would use sine.
Okay, so what's the equation?
So it'd be sine 65 is equal to x over 15. Or 15 over x, my bad.
So solve that equation.
Is equal to 15 over x. And then you would do sine 65 x is equal to 15.
Okay.
And then you would divide it by 15.
Not by 15.
Or by sine 55.
Sine of 65.
Or 65.
In other words, what we have to do is we're always trying to isolate x. Okay?
Right.
X is being multiplied by some number, the sine of 65. So we need to divide. Since this is multiplying x, we need to divide by this to get rid of it.
Right.
And that's actually the most exact answer you have. I know that they want the answer in terms of a number here. So you have to put that into your calculator. Do you have your calculator in front of you?
I don't. Believe it or not, I gave it to a friend yesterday, and he forgot to give it back to me today. So, I'll try to.
You're going to have it for your exam on Thursday?
I am.
Okay.
Yeah.
Good.
Yeah.
All right. Well, you know how to get this, right?
Yeah, definitely. You were just divided by sine 65.
Yeah, and you can do all this in one step. 15 divided by the sine of 65. Okay.
Exactly. Cool.
Well, let's look at 19 here. We have two similar cylinders. Determine the surface area of the larger cylinder. What ratio do they give us?
So they give us, well, they give us the surface areas and the volume of the
Now hold
two.
on, they don't give you both surface areas. What ratio do they give us?
Oh, the first surface area, 50 pi over 250 pi.
Look at both figures.
Uh-huh.
What do they give you for both figures?
The volume.
Volume. They're giving you the volume ratio.
Right.
Okay, so the volume ratio is what? Big to little. It's 686 pi over 250 pi.
Right.
Okay, well the pi's cancel out. What's the linear ratio?
The linear ratio would be,
How am I going to get it? In other words, you have three kinds of ratios. You have area ratio.
oh yeah,
Remember
the surface.
the linear ratio, whatever that is, the area ratio is the square of that.
Okay.
The volume ratio is the cube of this.
Okay.
So therefore, what's the linear ratio have to be?
The linear ratio has to be,
In other words, they're giving us the volume ratio. So how are we going to
right.
get back to the linear ratio? If we can get ourselves a linear ratio, then we can square it to get the area ratio. And that's what we need, really, is the area ratio.
Right.
Because before I can answer this question, I've got to figure out what the area ratio is.
Uh-huh.
Well, the easiest way to do it is to find out the linear ratio and then square it, and you'll get the area ratio. How do I get the linear ratio from the volume ratio?
From the volume ratio, you would cube it, right?
Take the cube root.
Right.
You're correct that the volume ratio is the cube of the linear ratio.
Right.
But I'm starting with the volume ratio. So if
Uh-huh.
it's a linear ratio, I got to take the cube root of that.
Uh-huh.
Okay? Well, that number is about 3.
Uh-huh.
I guess I have my calculator. Hold on.
No, you're good.
Let me turn it on.
Cool.
So if I want, this is why I'd rather you do it, is to make sure you can handle all of these little problems that might come up.
Right.
Cube roots. Well, to take a cube root of something, I'm going to raise it to the 1/3 power.
Uh-huh.
So I'm going to take 686. I'm going to divide it by 250.
Mm-hmm.
That is equal, interesting. That's equal to 343 over 125. In other words, had I simplified that, it would be 343 over 125. Well, notice what each of those numbers are.
They're perfect squares.
Perfect cubes.
Or perfect cubes, yeah.
In other words, if I want the cube root of this number,
Uh-huh.
I take the cube root of the top, which is, I believe, 7.
Uh-huh.
7 cubes is 343.
And then 5 times 5 times 5, yeah.
5 cubes. So the cube root of the bottom is 5. So this is the linear ratio.
Right.
Now, we still don't have, that's just the first step. Because in order to find the area ratio, the easiest way to do it is to find the linear ratio. What's the area ratio?
Then the area ratio would be 49 over 25.
Yeah.
Cool.
So now, that's what I have to work with. I know the area ratio is 49 over 25, and even though they say surface area, it's the same thing. In other words, linear ratio, area ratio, and volume ratio, it doesn't matter whether this is just an area or a surface area. The same math applies.
Okay.
So I'm going to say 49 is to 25 as what is to what?
So it'd be 49 is 25, or 49 over 25 is equal to 50 over 250. 50 pi over.
Compare surface areas, not.
Oh, that's right. So it's x over 686 pi.
No, that's not a surface area either.
No.
Surface area of the big cylinder is what we're trying to solve for. Let's call that x.
Okay.
Surface area of the little cylinder is 50 pi.
Okay. Yeah.
So, in other words, the area ratio, big to little, is 49 to 25.
Uh-huh.
So the surface area, big to little, has to be our unknown. We're trying to solve for the surface area of the big cylinder over the surface area of the small cylinder. So this has to be our ratio. And now we can go from there. How do I solve that equation?
You just cross multiply, so it'd be 25x is equal to 2,450. And then x is equal to 98.
2,450 pi.
Yeah.
So x is equal to 98 pi?
Yep, which is B. Yeah.
Okay, cool.
Cool. Awesome.
So all of those problems are exactly the same.
Right.
The only thing you need to know is that, here, let me make sure you know this. Let me start. In other words, if they give you an easy problem, they're going to give you the linear ratio.
Uh-huh.
Now let's say I have a linear ratio of 5 to 2.
Okay.
Meaning I have a square, one side of the bigger square is 5, the other side of the smaller square is 2.
Right.
So my linear ratio measured in inches or feet, a linear measurement is 5 to 2. What's my area ratio?
Then the area ratio would be 25 to 4.
And what is the volume ratio?
125 to 8. My bad.
Correct.
Cool.
Notice that that's only like 2.5 to 1.
Uh-huh.
That's 6 1/4 to 1, and that's 15 to 1.
Uh-huh.
So there's a huge difference in these ratios after you square them and cube them.
Yeah, for sure.
The difficulty of this problem was they gave you this one to start.
Yeah.
Gave you the volume ratio. So you had to take the cube root of it to get back to the linear ratio. And then you had to square that to get to the area ratio. So this was about as difficult of a problem as you're going to get in terms of these ratios. There's no harder thing to do. If they'd have given you the area ratio and wanted the volume ratio, well, that would have been about as difficult. I'd have had to take the square root to get the linear, and then I would have had to cube that to get the volume.
Right.
So that's also difficult, but not
for sure.
as difficult as this one probably is.
Yeah.
Right. Yeah.
Cool.
Look at this.
Yeah.
What am I going to use to solve this?
You would use sine, right?
Remember that you can only use trig functions on right triangles.
It's right, yeah, and it's not.
Not a right triangle.
No.
So you have to use, when you're solving triangles that are not right triangles, you have to use either the law of sines or the law of cosines.
Okay.
Which one are you going to use here?
You would use... How do you tell if it's cosine or sine?
Well, to use the law of sines, you have to have an angle and its opposite side relationship.
Oh, that's right. Side angle, side postulate.
Well, don't worry about that so much. Look at that triangle and see, the very first question you want to ask yourself is, for me, if I can solve this, what's this angle here, 63?
Yeah, 63. And then it's 415 on side AC and then 362 on side CB.
Well, notice that we do have an angle and opposite side values. And we have to have both. In other words, this can't be x. If that's x, I can't use the law of sines to solve it. But as long as I have a number there and an angle there, then I have the fixed relationship. So let's label it. Let's see, that's A, B, C. Yeah. So what's the law of sines say?
Law of sine.
What do they want us to solve for? They want us to solve for angle C.
Yeah.
So we can't immediately solve for angle C because we don't know angle C and we don't know the side opposite angle C. So we don't know either of those. So let's see if we can solve for angle A, because if you can solve for angle A, then you can figure out C, right?
Yeah, right.
By subtracting from 180.
Exactly.
So how can we solve for A? Let's start by trying to solve for A. Give me the law of sines as an equation for this problem.
Okay, so it'd be sine 63 over 415 is equal to x over 362.
I don't see an x.
So would just be angle A over
sine of A. Sine of A, not A. It's a difference between A and the sine of A.
Okay.
A is a measurement in degrees. The sine of A is a number. It's a ratio.
Right.
Okay. So once I set this up like this, there's only one variable in there. It's A.
Yeah.
But in order to solve for it, well, I wish I had your calculator because I need to make sure you can do this in your calculator. It's not automatic. Okay, so if we have one more session before your final, make sure you have your calculator.
Right.
The one you're going to use to take the final. Because the last thing, my biggest fear would be you'd get into your final and not know how to solve that in your calculator.
Right.
That would be inexcusable because of the hours we've put in here.
For sure.
I want to make sure you know how to do this. So what's the first step to solving that?
So you do sine 63 times 362.
Okay. That's equal to sine of A. We don't need to cross multiply. Notice that if we were to have cross multiplied, I would then have to immediately divide by 415. So cross multiplying is kind of self-defeating. Now we have the sine of A equal this number. How do we get A?
Is equal to sine of A. And then we would do sine of 63 times 362, or no.
You got to take the inverse sine of that number.
Right, so it'd be,
well,
inverse sine of 63.
That's why I wish you had your calculator, so that I could verify that you're able to do this in your calculator.
Oh, believe me, it's driving me nuts.
All right.
Yeah.
But that is what your answer is going to be.
Right.
And you can't cross off the inverse sine and the sine and leave 63. Doesn't produce the same thing. You could if it was just inverse sine of the sine of 63. Well, yes, that is equal to 63. But having all these other numbers attached to it matters. Because I'm not really taking the inverse sine of the sine of 63. I'm taking the inverse sine of this fraction times the sine of 63.
Right.
So, in other words, you would need to put that whole thing in your calculator. And that's going to give us angle A. Well, that's not what they asked for, but let's assume that angle A came out to be 57 degrees. Now, how do we get angle C?
Then you would just do 57 plus 63 and then subtract that from 180.
All right. Cool. And that's the way you would always do that problem. And there's no other ways to really do it. That's the only way to do that problem is by those exact steps.
Exactly. Yeah.
All right.
Cool.
Volume of the cone, find the cone's radius. Tell me the first step in this problem.
So we would set 147 pi equal to pi r squared times height.
Yeah, when I ask that question, what's the first step? What I would love to hear every single time is write the general equation.
General equation, yeah.
You gave me the equation, but it wasn't the general equation.
Uh-huh.
In other words, you gave me the specific equation for this particular cone. Well, actually, you did give me the general equation. But the general equation for the volume of a cone, what'd you give me again?
I gave 147 pi is equal to pi r squared times 9, or times height.
Actually not. That's not the general equation of a cone. And that's why it helps to start with the general equation.
Okay.
Remember, a cone goes to a point. When you see something going to a point, you better see a factor of 1/3.
Okay.
It's 1/3 times the volume of the same cylinder. If I had a cylinder that had this as the base and that was the height, then the volume would be the area of the base times the height. But for a cone, it's the area of the base, which is pi r squared, times the height, but it's times 1/3. And that 1/3 applies, all it has to do is go to a point. Doesn't have to be a cone. It can be a triangular pyramid, or it can be a square pyramid. There can be anything that goes to a point is going to be 1/3 of the volume that it would be if it was a prism.
Okay.
In other words, turn that thing into a prism, you have a right cylinder, right?
Right.
Okay, well, if somebody gave you a right cylinder of soap and they said carve it into a cone, you would have to carve away 2/3 of the volume.
Mm-hmm.
It's the only way you'd be able to make a cone that had the same height as the original cylinder.
Right.
Okay. So now that we've got the proper general equation, let's plug in everything we know. Well, they told us the volume. And they gave us the height of 9.
Yeah.
Solve that.
Okay. So the pi's would cancel out. So it'd be 147 is equal to 1/3 r squared times 9.
Combine the 1/3 and the 9.
So let's see here.
1/3 times 9. What's 1/3 of 9?
1/3 3.
Okay, so let's combine it and make a 3 there.
Yeah.
Now what?
And then you would do, let me see, you would subtract 3. So it'd be...
Hold on, let's get this straight, because you make this mistake a lot.
Okay.
You take a number that we're multiplying by our variable. You're not going to subtract to get rid of that 3.
Right.
You have to do the inverse of what the 3 is doing. And the 3 is multiplying right now.
Okay, so you divide by 3.
Gotta divide.
Okay.
Always have to do the inverse. Okay?
Right.
So now that's going to leave. That 3 is going to cancel with that. And I got r squared over here.
It's equal to 49.
49. Yeah, you're right. Sorry.
No, you're good.
And what's r equal to?
To 7.
Okay. And that's what they wanted, correct?
Yep. Mm-hmm.
All right.
Exactly, yeah.
I'm finding getting over my cold, although probably you can still hear it a little bit in my voice, but I feel so much better than I did the last week was horrible.
Oh, man, yeah.
And I can hear the allergies in your sniffles. I hope they're allergies.
Oh, yeah.
Cold.
I hope they are too. I mean, I feel like they are, like my
Yeah,
dog.
I don't know. I was trying to figure out whether I preferred having allergies or a cold. A cold will
Right.
go away in a couple of weeks. Allergies,
They stick with you.
5 weeks.
Exactly.
You can't
Yeah.
tell the difference. You're just as miserable with either one. So,
Yeah.
uh,
Exactly. Yeah. Oh man, my
this is
my
why you
dog.
put
I tell you.
yourself in a burning building and nobody saves her. Oh, excuse me. No.
Ouch.
He was waiting to be rescued in a window 28 feet above the ground. When the firemen arrived with a 35-foot ladder, at what angle of elevation did the firemen place the ladder to rescue her? Well, let's draw a picture. Always draw a picture.
Yeah, for sure.
He's waiting 28 feet above the ground. They're going to come and lay a ladder so they can rescue her.
Yep, which is 35
Ladder
feet.
35 feet. So what they want is this, and these questions always result in right triangles.
Yeah, for sure.
Because buildings are always built perpendicularly to the ground, and trees always stand perpendicular to the ground, and people always stand perpendicular to the ground. So all these problems, the thing that's standing is perpendicular to the ground.
Right, yeah.
So they're asking, what is the angle of elevation?
Okay. So you would
What angle of
use...
elevation do the firemen need to place their ladder? And it's not immediately clear whether they're talking theta or x.
No.
So you kind of have to think of, okay, if I'm a fireman down here and I want to place my ladder in an angle, it's this angle that I care about, right?
Yeah.
So that must be the angle they're asking about.
Yeah, for sure.
Okay, what trig equation? Don't need the law of sines or cosines because this is a right triangle.
Okay.
So what trig equation, and let me erase x, what trig equation relates theta, 28, and 35?
Okay. Okay. So we would use sine, the law of sine for this one.
Not the law of sines. It's not the law of sines. It's the sine function.
Or sine, yeah.
We're not going to use the law of sines. We only use the law of sines and cosines if it's not a right triangle.
Okay.
All right triangles, you can use sine, cosine, or tangent to solve them.
Yeah.
And that's all you need. You don't need any of those laws. Okay. So what's the equation I can write?
So it'd be sine A over 1
Hold on.
is equal to...
I don't see an A.
Would it just be sine...
You take trig functions of angles.
Sine 90 then.
Sine theta.
Theta. Okay.
That's what they're asking for, is theta.
Yeah.
In other words, I could have labeled that x, and then it would have been the sine of x, but they ask for the angle, so I use a Greek letter theta to represent the angle. What's it equal to?
28 over 35.
Okay, now how do I solve for theta?
And then we would do sine theta times 35 divided by 28.
No.
Or sine 28.
In other words, we've almost got it solved right there.
Yeah.
We've solved for the sine of theta. Well, how do you get theta? If sine is equal to that, what's theta equal to?
Would you do inverse sine?
Yeah, when you're solving for angles, it's always the inverse trig function.
Right.
And I can even put that in as that. I don't have to worry about simplifying it because the calculator will do it for me.
Right.
Even though that number is 4 over 5, don't worry about going to the effort of simplifying it because this is not your answer. That's just a mid-step to get the answer. In other words, if you put this thing into your calculator, the inverse sine of this ratio, you'll end up with an angle. I don't know what it is, but it's like 62 degrees, let's say. So theta is going to equal that. In other words, whenever we take the inverse trig function, we're going to get an angle.
Okay.
You have to make sure your calculator probably is in degrees. You probably never put it into radians.
I don't think so, yeah.
Yeah, so it actually gets tougher as you go into trig, because when you deal with trig, you can have your calculator in degrees or radians. And
Right.
you don't know which it is in, you can make some serious mistakes. And so, and it's not that easy to tell which it's in. And unfortunately, the calculators they make, there's not an easy way to tell whether you're in radians or degrees. The TI-84 is probably the easiest to tell what
Right.
you're in. But
Yeah.
anyway, always remember that you take trig functions of angles to get ratios. You take inverse trig functions of ratios to get angles.
Okay.
Okay?
Awesome. Cool.
And I don't know what that angle is. Certainly not 90 degrees, right?
No, definitely not.
Well, because you can't lay a ladder. If this was 90 degrees, the ladder would be laid like that.
Right, and it'd fall.
Well, it would be 35 feet tall, and
yeah.
Well, actually, you know what? That would almost work, but you're right. It would fall in this direction.
Right.
So they never want to lay it vertically. They want to lay it laying up against the building. And tall enough so that they can lay it up against the building and still reach the 28th floor. So that's why they need to know that angle.
Right.
To make sure that it'll reach. If they use too small of an angle, the ladder's going to not reach the 28th floor. It's going to reach floor 27. This is the 28th floor right there.
Right.
So it's not an inconsequential question. In other words, if they know they have a 35-foot ladder and she's on the 28th floor, they better get this angle right. If they don't get it right, they may not save her life.
No. She'll die.
Yeah. Miss Moore would not be happy.
No. Nope. Nope.
All right. Is this the only page we're doing tonight?
That's the only page, we had tonight, so I think.
Well.
Yeah. Well, all right.
Yeah, let's see. Let me just check the schedule here, make sure you got. I
think we have 8:30 tomorrow, right?
Yeah, I've got you down for half-hour appointments Tuesday and Wednesday.
Perfect.
So that sounds like it'll work just right.
Awesome.
And I'll make a half-hour appointment tonight. So.
Okay, cool.
Thank you for this.
Yeah.
It's been a busy day.
Definitely. Oh, man.
As the whole week will be. Of course, and then I'll be nothing to do. Once,
when summer break comes, right?
Once this week is over, then I tend to have very little to do. So, anyway.
Exactly.
All right, Dylan. Yeah, you'll be having fun playing baseball.
Oh, that'll be so much fun. Yeah.
Yeah, I'll bet you can't wait for summer.
Oh, I can't wait. We get all of our equipment tomorrow, like for our team, so that's going to be a lot
Really?
of fun.
Your uniforms and stuff?
We do. We get 3 jerseys, 2 pants, and a bunch of other stuff. So
Great.
It's going to be real fun. Yeah.
Wow.
Yeah.
Cool. All right, Dylan. I'll talk to you tomorrow.
All right. Sounds good. I'll see you tomorrow.
All right. Bye-bye.
All right. Thanks for scouting.